morning and welcome back to Brodeur. We are in week 6. We're about to wrap up week 6. We still have 2 days, so we are currently day 4 right now, which means we're getting close to that finish line. This is our last week of work, so let's finish strong. So what is today's lesson today? So today we're going to look at dilation, and our learning intention says students can dilate a two-dimensional figure on a graph and understand that the pre-image is similar to the image or second dilated figure. So what exactly is dilation? Well, how can we do it? So first, before we go into dilation, one way that you might hear or you've maybe heard of dilation is with your eye. For example, my pupil right here, depending on how much light comes into my eye, our pupils either dilate smaller or larger to take in the amount of light that's necessary to see properly. And that's kind of what we're going to do here with our images, is we're going to dilate images to where they either increase in size or decrease in size. And so let's take a look. We're going to take a look at some of our examples over here. So let me grab my markers and stuff. So today you actually got a little lucky. I think we only have 3 questions today that you have to complete. Right here, these are the first 2 examples, or sorry, practice problems that you need to complete. I'm going to do the first one together with you. I'm going to start the second one, but I'm going to have you finish the second one and then of course finish the third one that you have. So let's take a look at example 1. It says dilate the pre-image with a scale factor of 1/2. So if I look at my graph, I got my pre-image right here, my original image. Now, what I want to do first is find out what my scale factor is. So my scale factor is 1/2, and what I would do is I would write that down, and let me get my blue marker out. So my scale factor here is 1/2. And the reason I need that is I'm going to have to use that in a little bit to find my final image point. So let's go right here. What I need to do first is go to my image and find my original point. So V right here, I'm going to go at the origin. Always start at the origin when you're finding your coordinates. I'm going to go 1, 2, 3, 4. So that's going to give me 4, -1, because we had to go down 1 from our x-axis. J right here is going to go left 1, so that's going to give me -1, and then down 2, so that's -2. And then K right here, let's see, K is right there, so starting at origin 1, 2, so that would be 2, and then down 2, 3, 4. But be careful, that would be a -4 right there. Let me write that a little bit better. Should be -4. Okay, so these are my original points. I got my scale factor. We pretty much have everything we need in order to get our prime points or our final image points. What you need to do is take your scale factor, okay, and let me get out another pen to show this. And you just got to multiply, in this case 1/2, to every number in our coordinates. For example, let's take a look at V. V has 4 as its first x coordinate. I'm going to take my 4 and multiply it by my scale factor. Now, if you're wondering how in the world do I do this? Well, if you remember, 4 times 1/2, some people might just know that is 2. But let's say you're like, Mr. Brodeur, I'm really not good with fractions. How did you get 2? Well, remember 4 we could write as 4/1. So anytime you do not have a fraction, you just take that number, write it over 1, and then times 1/2. So 4 times 1, now you just multiply straight across. 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 gives you 2. So that's kind of the long way on multiplying with a fraction. Really what's going to happen though is when you multiply by 1/2, you're really dividing everything by 2 right there. Okay, but I didn't want to just say that. I wanted to show you how we get that. So now we're just going to write our answers. So 4 divided by 2, we just found that as 2. Negative 1 divided by 2 is negative 0.5. Now some people might say, Mr. Brodeur, I had negative 1/2. Why can't I just write negative 1/2? You can, but negative 0.5, its decimal form, is going to be a lot more easier to graph than negative 1/2. So I would change that to a decimal right there. Same thing here. Negative 1 divided by 2 is negative 0.5. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. And then negative 4 divided by 2 is negative 2. So I got all of my prime points, or my new image points. And your last step here is you just need to go plot these. So let's go plot these. Now I know some people already might be thinking, how in the world do I plot a negative 0.5? It's not bad. All you got to do first is let's go to 2, because it says we got to go to 2 first. Now negative means I'm going to go down, but I'm not going to go all the way to 1. I got to go to 0.5, which would be in between. So I'm not going all the way. I'm going to go halfway right there. So see how I just went halfway between 0 and 1. And then I'll mark that as V prime. J, I'm going to go not negative 1, but negative 0.5. Whoops, sorry, not right there. That's where I'm going to go first, but now I'm going to go down to negative 1 at J prime. So sorry, that point should not be there. I needed to go all the way down. K, I'm going to go to 1 and then negative 2. Luckily, that one didn't have any decimals really to deal with. So K prime. And remember, put your primes there for all the points and also label as you go. Now, notice when I go to connect these points right here, all right, our shapes should look similar in the sense that, you know, they have the same kind of shape. However, you might say, Mr. Brodeur, our original, our pre-image was a lot larger than our image or our final image right there. And that's what dilation does. Dilation either shrinks or decreases the size of your image or increases it. And so these would not be congruent like our other ones we've been doing, like rotations, reflections, translations. They were congruent. We didn't increase or decrease the size. Here, when you increase or decrease the size, you get a similarity, but no congruencies. Now, if you're wondering, Mr. Brodeur, what does similarity mean and all that stuff? We're going to dive into that tomorrow, so we'll get more into that tomorrow. But for now, let's just focus on dilations. Now, example 2, I wanted to start this one, but let you guys finish it. The reason I wanted to start is you might notice there's absolutely nothing on this graph. Over in example 1, we had something already originally on this graph. But they do give us the points. It says plot the pre-image with A, 1, 2, B, negative 2, 1, and C, 2, negative 2, and then dilate with the scale factor of 2. So all I would do here is just plot my points. So A, I would go 1 up to 2 right here. We'll call that one A. B, negative 2, 1. And C, we got 2, negative 2 right there. And we'll just connect our points. Now, the main thing is on your work, you need to show both pre-image and then your image at the end. Kind of like what we did here. You have your pre-image, you have your image at the end. So I got my pre-image. Now, we just do the same thing we did here. You got your scale factor, which is 2. Now, I don't necessarily have to write my coordinates down because I already have them in my problem. So now I'm just going to take my scale factor and multiply by 2. So for example, if I'm taking A right here, 1, 2, all I got to do is take my scale factor, similar to what I did here, and just multiply. But with these, I'm going to multiply them by 2. So 1 times 2 gives me 2. 2 times 2 gives me 4. And then just keep doing that with B and C. I'm going to let you guys finish that up, but I just wanted to kind of get you started since this one was a little different. And then you should have one more problem after this on your paper that you need to complete. So make sure you get these two down and your third problem down on your paper. But just let me know if you got any questions, or let your teachers know if you got any questions. But until next time, Brodeur out. Peace.